Welcome back to the deep dive. Today, we're going to try to tackle something pretty ambitious, exploring a theory that tries to reimagine how we understand reality itself.
A framework that attempts to bridge science and philosophy, even touches on some theological concepts. It's called the size-scale theorem, sometimes called the infinite size range theorem.
So what exactly does that mean, infinite size range?
Well, it suggests that reality is not made up of separate, isolated pieces as we often perceive them, but rather it's one continuous, unbounded, infinite entity.
Okay, I'm intrigued already. So where do we even begin to unpack a concept this vast?
The size-scale theorem, it's built on three main ideas, often referred to as pillars.
Pillars, okay.
The first is this concept of infinite size range. The second is energy-mass spacetime. And the third one's a bit of a head-scratcher. Distinction, anti-distinction opposition.
All right, let's break this down one by one. Infinite size range, I think I can kind of intuitively grasp that, but how would you explain it?
Think of it this way. We all know there's no smallest thing, no largest thing. You can zoom in on an atom, you find electrons, protons, quarks, and theoretically you could keep going forever. Same thing when you zoom out. Planets, stars, galaxies, and beyond. It never ends.
So it's like those Russian nesting dolls. But instead of stopping at the smallest doll, you just keep going infinitely smaller and bigger.
Exactly. The theorem challenges us to think beyond those limits we normally place on scale. No matter how large or small something is, there's always something larger and smaller.
Makes you realize how our human perception of scale is pretty limited.
And that's a key point. This theory is all about challenging our perception, pushing us to see beyond the boundaries we often take for granted.
Okay, I'm starting to see where this is going. What about the second pillar? Energy mass spacetime. That sounds pretty sci-fi to me.
It might sound futuristic, but it actually stems from a very familiar concept, Einstein's famous equation, E must c A.
Ah, yes, energy equals mass times the speed of light squared. Possibly the most famous equation in physics.
Right. And the size-scale theorem takes that concept a step further, proposing that energy, mass, space, and time are not separate entities, but rather interwoven aspects of a single entity. They can't exist independently of each other.
So instead of thinking of them as separate ingredients, it's more like they're all different expressions of the same fundamental reality.
That's a great way to put it. It suggests that everything we observe is simply a different manifestation of this underlying entity.
All right, that one's starting to sink in, though. I have a feeling it's going to take a while to fully grasp the implications. Now, what about this third pillar? Distinction, anti-distinction, opposition. That one sounds like we're venturing into some seriously deep philosophical waters.
This is where the theory really challenges how we perceive and categorize the world. We humans, we love to define, to categorize, to draw boundaries. That's what we mean by distinction. We see a tree, a rock, a person, and our minds automatically label and categorize them as separate, distinct entities.
That's how we make sense of the world, right? Put things in boxes.
Exactly. But the size-scale theorem suggests that those boundaries are ultimately artificial. It proposes that reality itself is a seamless continuum, a concept referred to as anti-distinction. And when we try to hold these two ideas, the inherent unity of everything versus our need to categorize, it creates a paradox, which is where opposition comes in.
So it's like our very act of thinking and labeling creates a separation that doesn't truly exist in the underlying reality.
Precisely. Our language, scientific models, even the diagrams we'll be looking at later, they're all tools to help us navigate, but they're not the territory itself. The map is not the terrain.
It's like realizing the lines on a map are just arbitrary boundaries, but in reality, it's all one continuous landscape.
That's a great analogy. And that's exactly the kind of shift in perspective this theorem invites us to make.
So we've got this idea of an infinite continuum of energy, mass, space-time, and our attempts to categorize and define it actually create a kind of artificial separation. I have to admit, my brain's starting to feel a bit overloaded.
We'll hold on tight because things are about to get even more mind-bending. You mentioned diagrams earlier, and those visual representations will be our next stop on this deep dive.
Bring it on. I'm ready to see if these diagrams can help shed some light on these complex concepts. Let's start with the one showing those stacked infinity symbols and EMCC right in the middle. What's going on there?
This diagram is like a visual metaphor for the infinite size range. The stacked infinity symbols above and below tell us that it goes forever in both directions, larger and smaller.
Okay.
No matter how far you zoom in or out, there's no endpoint.
So it's a visual representation of that boundless continuum we were just talking about.
Exactly. And that EMCC in the center serves as a reminder that this entire continuum, from the infinitesimally small to the infinitely large, is made up of the same fundamental stuff, energy, mass, spacetime.
So it's emphasizing that interconnectedness, that everything is ultimately just a different expression of this single entity.
Precisely. It's all part of the same cosmic dance, and this diagram is trying to capture that in a visual form.
Okay, I'm starting to get a feel for what this diagram is trying to convey, but I have to admit the other elements in this diagram are a bit confusing. There's cogito distinction, anti-distinction, even synonyms thrown in there. It's a lot to take in.
It can be overwhelming at first glance, but they all point to the same core concept we were discussing earlier: the tension between our human need to create distinctions and the inherent unity of reality. The word cogito, meaning I think in Latin, it's used here to represent how our minds work. We think, and therefore we separate.
So it's basically saying our thinking process naturally leads to creating distinctions.
Exactly. And as we discussed, anti-distinction represents the underlying unity of everything, that boundless continuum that exists beyond our labels and categories.
And what about those synonyms? Manual, plural, distinct? They seem to be emphasizing the idea of separation.
Precisely. They're highlighting how our language and thought processes constantly divide the world into separate pieces. But the size-scale theorem urges us to look beyond those pieces, to recognize that underlying wholeness.
This is starting to make more sense. It's like those optical illusions where you can see two different images depending on how you look at it. We can focus on the separate parts or shift our perspective to see the bigger picture, the unified whole.
That's a great way to put it. And that's exactly what this diagram encourages us to do, to hold both perspectives in mind, to recognize the paradox and embrace the mystery.
No wonder you said this theorem bridges science, philosophy, and even theology. It's definitely making me rethink some fundamental assumptions about how I see the world.
And we've only just begun to scratch the surface. There are two more diagrams that offer even deeper insights into the size-scale theorem, and those are next on our agenda.
Perfect. I'm ready to dive even deeper. Let's move on to the next diagram, the one that depicts Realm 1, Thought Thinker, and Reality, with Insia and Intertwinedness.
All right, take a look at that diagram. What are some of the first things you notice?
Well, it seems to be dividing things into two sides. On the left, we have thought, separation, thinker, all those concepts we were just discussing. And on the right, it says reality and points to EBO spy and intertwinedness. It feels like it's setting up a contrast.
That's a great observation. This diagram is visually representing that fundamental opposition we talked about earlier, the tension between how our minds work, which relies on separation and distinction, and the true nature of reality, which is ultimately interconnected and unified.
So the left side is basically our human experience, how our brains make sense of the world.
Exactly. It represents Realm 1, where we perceive a world of separate objects and categories. We see a tree as distinct from a rock, a person is separate from their surroundings.
And the right side represents the real reality, where everything is actually part of this one big energy-mass-space-time continuum.
Precisely. The diagram is visually highlighting that our perception of separation is just that, a perception. It's a useful tool for navigating the world, but it doesn't reflect the underlying unity of everything.
Yeah.
And that unity, as the diagram emphasizes, is rooted in the very fabric of energy-mass-space-time, represented by EM and CA.
It's like we're looking at the world through a filter that creates the illusion of separateness. But if we could remove that filter, we'd see that it's all interconnected.
You've got it. And it's important to remember, as the diagram points out, that any representation of this interconnectedness will inevitably introduce some degree of separation. There's a note here that says, representation intertwinedness, because representation, separation.
So even this diagram itself, which is trying to show us the interconnectedness of everything, is ultimately a representation that creates a degree of artificial separation. That's a bit paradoxical, isn't it?
It is. It highlights the inherent challenge of trying to grasp the infinite with our finite minds. We need representations to understand, but we have to remember that the representation is not the thing itself.
It's like trying to capture the ocean in a bucket. You can get a glimpse of it, but you'll never capture its vastness, its interconnectedness.
A perfect analogy. The ocean is a great way to visualize this concept of anti-distinction. It's one vast, interconnected body of water. But we draw lines on maps, give names to different currents and regions, creating the illusion of separateness.
Okay, I'm really starting to see how this theorem challenges our conventional way of thinking. It's like it's asking us to zoom out, way out, and consider a much bigger picture.
And that's precisely what the size-scale theorem invites us to do, to take that intellectual leap and consider a more holistic view of reality.
This has been an incredibly insightful deep dive so far. I'm eager to hear more about the third diagram and explore the wider implications of this theory. Where do we go from here?
Let's shift our focus to the universal diagram, metaphysics. It offers a slightly different way to visualize the concept of the infinite size range and how we as humans fit into this grand cosmic scheme.
Okay, let's see what this third diagram has to offer. I'm looking at it now, and the first thing that jumps out at me is this vertical axis. It has quantum at the bottom, humans somewhere in the middle, and cosmology at the top. And it looks like it just keeps going in both directions with those familiar infinity symbols at either end.
Exactly. This diagram visually reinforces the concept of the infinite size range, showing that no matter what scale we're looking at, whether it's the subatomic realm, the human scale, or the vast expanse of the cosmos, there's always something bigger and something smaller. No ultimate boundaries in either direction.
It's like another version of that cosmic zoom, reminding us there's always more to discover no matter how far we explore.
Precisely. The universe is endlessly vast and endlessly intricate. This diagram is a reminder of that mind-boggling scale.
It's both exhilarating and a little bit terrifying to think about. It definitely puts things in perspective.
That's the beauty of this framework. It inspires both awe and humility. It helps us see our place in the universe in a whole new light. And remember, as always, EMC is right there in the middle, connecting it all together.
Right, it's that constant thread reminding us that this entire continuum is woven from the same fabric of energy mass spacetime. But this diagram also seems to highlight the human perspective in a unique way. There are references to the brain, left and right hemispheres, even the old brain. What's the significance of that?
This is where the diagram connects the vastness of the cosmos to our own embodied experience. It suggests that even our human brains, with their intricate structures and capabilities, are simply part of this grand continuum. Our thoughts, our emotions, our very consciousness, it's all arising from the same fundamental stuff that makes up stars and galaxies.
So it's not just about the physical universe out there, but also about our inner world, our subjective experience.
Exactly. It's a reminder that we're not separate from the cosmos, but rather intimately connected to it. We're not just observing the universe, we're participating in it.
That's a profound thought. It makes you wonder if our consciousness, our ability to reflect and ponder the universe, is somehow woven into the fabric of reality itself.
That's a question that philosophers and scientists have been grappling with for centuries. And the size-scale theorem offers a fascinating lens through which to explore such questions.
Okay, my mind is officially blown, but before we move on, I want to make sure I understand this text at the bottom of the diagram. It says, there is no maximum nor minimum size in anti-distinction because such borders would be distinctions. And it also says that even the biggest representation can't fully capture anti-distinction because of anti-distinction opposition. Can you break that down for me?
It's reiterating the key paradox we've been discussing, our inherent need to create distinctions to understand reality, even though those distinctions don't actually exist in the underlying continuum. No matter how big or small we make our models, our representations, they will always be finite attempts to grasp something infinite. And that very act of defining a boundary, a limit, introduces a distinction that isn't truly there.
So even if we could create a model of the entire universe, it would still fall short of capturing the true nature of reality, because the model itself would create a boundary.
Precisely. The model, the representation, would inherently introduce a separation between what's inside the model and what's outside, even if there's no outside in the ultimate sense.
That's a humbling thought. It really highlights the limitations of our human minds, our need to categorize and define, even when dealing with something as boundless as the universe.
And that humility, I believe, is one of the greatest gifts of the size-scale theorem. It encourages us to approach reality with a sense of wonder and awe, recognizing that we'll never fully grasp its infinite depths. It's about embracing the mystery, letting go of our need for all the answers.
I'm really starting to appreciate that aspect of this theory. It's not about finding all the answers, but rather about expanding our perspective, opening ourselves up to new possibilities.
And that's what makes this exploration so exciting. We've just scratched the surface of the size-scale theorem. Now it's time to shift gears and explore why you, the listener, should care about this theory. What are the real-world implications? How does it change our approach to science, philosophy, and even our everyday lives?
I'm definitely ready for that. We've explored these mind-bending diagrams and unpacked some complex concepts, but now I want to know how it all connects to the bigger picture. Bring on the so what.
All right, let's shift gears a bit and talk about why you should care about this size-scale theorem. It's not just some abstract intellectual exercise. It has real implications for how we understand and approach some of the biggest questions facing humanity.
Okay, I'm all ears. This theorem seems to touch on everything from the nature of reality to the meaning of life. But how does it translate into something tangible?
Let's start with science. Imagine scientists trying to find a theory of everything, a single framework that explains all the forces and particles in the universe. They often look for fundamental building blocks, those smallest indivisible units of reality.
Right, like the famous God particle, the Higgs boson.
Exactly. But what if, as the size-scale theorem suggests, reality is fundamentally continuous? What if there are no ultimate building blocks, no smallest piece to find?
So instead of a finite set of building blocks, it just keeps going smaller and smaller forever. Wouldn't that make the search for a unified theory pointless?
That's one of the mind-blowing implications of this theory. If reality is an infinite continuum, then those fundamental particles we're searching for might just be convenient approximations, useful distinctions within a boundless whole.
So it's like those maps we talked about earlier. We draw lines and create countries and borders, but the Earth itself is one continuous surface.
That's a great analogy. And this shift in perspective could have a profound impact on how we approach scientific research. Instead of always looking for smaller and smaller pieces, we might start focusing more on the relationships and connections between things.
Instead of reductionism, a more holistic approach.
Exactly. How do different scales interact and influence each other? What are the emergent properties that arise from those interactions? These are the types of questions that the size-scale theorem pushes us to consider.
That's fascinating. It really challenges the traditional scientific method of breaking things down to their smallest parts. It's like saying the whole is greater than the sum of its parts.
That's the heart of it. The size-scale theorem, it encourages us to think in terms of systems, networks, interconnectedness.
Okay, I'm starting to see how this could revolutionize scientific thinking. But what about philosophy? How does this theorem change our understanding of ourselves and our place in the universe?
That's where things get even more interesting. One of the most profound implications is the way this framework redefines the concept of God.
Okay, now we're really getting into the deep stuff. I'm definitely curious to hear more about this.
Think about it. Many traditional religions depict God as a being separate from creation, a supernatural force that exists out there somewhere.
Right, the classic image of God is a bearded man in the clouds.
Exactly. But the size-scale theorem offers a very different perspective. If reality is this infinite interconnected continuum of energy, mass, space-time, then God could be understood as the totality of that continuum itself.
So instead of a being who created the universe, God is the universe itself.
In a sense, yes. It's a non-anthropomorphic pantheistic view, where the divine is not a separate entity, but rather the very fabric of reality, the interconnectedness of everything.
That's a pretty radical shift in perspective. It's like saying the divine isn't out there somewhere, but rather right here, right now, woven into the very essence of who we are and everything around us.
Exactly. It's a vision of deep interconnectedness, of unity with something much greater than ourselves. And this has profound implications for how we view ourselves and our relationship to the universe.
It almost sounds like a scientific basis for spirituality.
That's a great way to put it. The size-scale theorem doesn't negate traditional religious beliefs, but it offers a new lens through which to interpret them.
It's like it's building a bridge between science and spirituality, two realms that are often seen as separate or even opposed.
That bridge-building aspect is crucial. In a world so often divided by religious and ideological differences, this theorem offers a potential common ground, a shared understanding that transcends cultural and historical boundaries.
It's like it's saying, hey, we're all part of this same cosmic dance, whether we believe in a personal God or not. We're all interconnected, all manifestations of this one incredible reality.
That's the essence of it. And that realization can be a powerful force for empathy, compassion, understanding. If we truly grasp the interconnectedness of everything, then the idea of us versus them starts to dissolve.
Wow, that's powerful. It really makes you rethink those arbitrary lines we draw between people and groups.
And it goes beyond just human relationships. The size-scale theorem also has profound implications for how we treat the planet.
Yeah, I can see how this idea of interconnectedness could lead to a more eco-conscious worldview.
If we recognize that we're not separate from nature, but rather part of this interconnected web of life, then our actions take on a whole new level of significance.
It's like that saying, harm to one is harm to all, but on a cosmic scale.
Exactly. It challenges us to move beyond a purely human-centered view of the world and recognize the intrinsic value of all life, of the entire ecosystem. It's a call to environmental stewardship.
So this isn't just a theoretical framework, it has real-world implications for how we live our lives, how we interact with each other and the planet.
Absolutely. It's about understanding our interconnectedness and acting accordingly. The size-scale theorem pushes us to recognize that our actions have consequences that ripple out through the entire web of life.
It's a pretty powerful call to conscious living and mindful action.
And it extends to how we approach global challenges, like climate change, poverty, conflict. The size-scale theorem provides a new framework for understanding these complex issues.
I'm curious to hear more about that. How can this theorem help us tackle such massive problems?
Well, it starts with recognizing that these issues are not isolated. They're all interconnected, stemming from the same root causes. Take climate change, for example. It's often seen as purely an environmental issue, but it's deeply intertwined with economic inequality, social injustice, and political instability.
So it's not just about reducing carbon emissions, it's about addressing systemic issues like poverty, overconsumption, and the unequal distribution of resources.
Precisely. And the size-scale theorem provides a framework for understanding these interconnections, for seeing the bigger picture and recognizing the need for systemic change.
It's a reminder that we can't solve these problems in isolation. We need to collaborate, to take collective action, and to recognize that we're all in this together.
That's the power of the size-scale theorem. It's not just a theory about the nature of reality, it's a call to action.
This is blowing my mind wide open. We've gone from decoding mind-bending diagrams to unpacking the ethical implications of this theory. It's made me question everything I thought I knew about reality.
And we're not done yet. There's one more fascinating aspect of the size-scale theorem that we haven't even touched on. And it has to do with the very nature of consciousness and its role in this grand cosmic scheme.
Okay, you've definitely piqued my curiosity. I'm ready to dive even deeper into this rabbit hole. What's next on our journey of exploration? So we're back, and I gotta say, my mind is still buzzing from all these mind-blowing implications of the size-scale theorem. But now we're about to tackle perhaps the biggest mystery of them all, consciousness.
This is where the size-scale theorem gets really speculative but also incredibly exciting. It pushes us to consider the possibility that consciousness is not simply a byproduct of our complex brains, but rather a fundamental aspect of reality itself.
Okay, hold on a second. That's a pretty radical idea. Isn't that contradicting everything we know about biology and neuroscience?
It definitely challenges the conventional view. But think about it this way. If reality is this interconnected continuum of energy-mass-spacetime, as the theorem suggests, then maybe consciousness is woven into the very fabric of that continuum.
So instead of consciousness emerging from matter, you're saying it's the other way around, that matter emerges from consciousness. That's a pretty huge leap.
It is a radical shift in perspective, but it aligns with some ancient philosophical and spiritual traditions that see consciousness as the ground of all being. It's not a new idea, but this theorem gives it a fresh perspective.
I'm trying to wrap my head around this. It's like saying the universe isn't just a giant machine, but a giant mind.
That's a powerful metaphor, and it raises all sorts of fascinating questions. If consciousness is fundamental, does that mean everything in the universe is, in some sense, aware? Do rocks have consciousness? Do stars?
Okay, now you're really getting into the realm of science fiction. I'm not sure I'm ready to start having conversations with rocks just yet.
I understand your skepticism, and it's important to approach these ideas with a healthy dose of critical thinking. But even if we don't go as far as attributing consciousness to inanimate objects, the idea that consciousness is woven into the fabric of reality opens up some incredible possibilities.
Like what? Give me an example.
Well, think about the role of the observer in quantum mechanics. Experiments have shown that the act of observation can actually influence the behavior of subatomic particles. Yeah. It's as if our consciousness is somehow entangled with the quantum world.
So you're saying that maybe our minds aren't just passively observing the universe, but actively participating in its creation. That's pretty mind-blowing.
Exactly. It suggests that consciousness might be a force, an energy, that shapes and influences reality at the most fundamental level. And the size-scale theorem provides a framework for exploring these ideas in a way that uses science and spirituality.
It's like it's opening up a whole new frontier of scientific inquiry, one that includes consciousness as a fundamental part of the equation.
And it challenges us to reconsider our place in the universe. If consciousness is not just a byproduct of our brains, but a fundamental aspect of reality, then we're not just insignificant specks in a vast, indifferent cosmos.
We're active participants, co-creators of reality.
That's a key takeaway from the size-scale theorem. It's a call to recognize our interconnectedness, our potential to shape and influence the world around us, not just through our actions, but through our very consciousness.
This has been an incredible deep dive. We've explored the nature of reality, the meaning of God, the interconnectedness of everything, and even the role of consciousness in shaping the universe. You've given me a whole new way of looking at the world.
It's been a pleasure sharing these ideas with you. I hope this exploration has sparked a sense of wonder and a new appreciation for the interconnectedness of it all.
It definitely has. My mind is buzzing with possibilities. And to our listeners out there, we leave you with this. If reality truly is this infinite, interconnected continuum, what role does your consciousness play in shaping it? What possibilities are you opening up to? What kind of world do you want to co-create?
The journey of discovery never ends. Keep exploring, keep wondering, and keep diving deep.
Thanks for joining us on the Deep Dive. Until next time, stay curious.